Today is finally our last lesson for Module 1. We are going to continue looking at percent problems. We're going to continue looking at the three parts, the percent, the part, and the whole, and percent of a quantity. So let's take a look at our notes. Just like in ELA, we can have a claim in math also. So somebody made a claim to find 10% of a number. All you need to do is move the decimal to the left once. So right now, make a prediction. You know from science, look, it's all coming together. Science, ELA, math. Doesn't matter if your prediction comes true or not. Right now on your notes, write yes or no and explain your answer. Is it true? Everybody should be writing their pencils on their paper. Do you think the claim is true or false? That when you find 10% of a number, you're just moving the decimal place, one decimal point, one place to the left. Please write this down. Now we have several examples that we're going to solve together to see if we can prove this statement true or to disprove it, to say that the statement is false. Now the directions said that for at least one of them, we need to use a model to solve it. So let's take a look at choice B. 10% of 300. So I know that's my total. So 10% is 10 out of 100 of 300. So what does x equal? I think we can all see that. Times 3. So that means I have to times 3. So what is 10% of 300? 30. Let's do it again. 10% of 100 equals what part of 80? Well, I can't evenly get from 80 to 100. So what I'm going to do is reduce that to 1/10. Now can I see the relationship between those two ratios?
Yes.
Yes. So what did I do?
Times by 10.
Times 8. So 1 times 8 is 8. So 8 is 10% of 80. Let's try the next one. 10% is the same thing as 10 over 100 because percent always means out of 100 equals what part of 64? Now I'm going to think ahead here a minute. If I reduce that to 1/10, am I still going to be able to get from 10 to 64?
No.
No. What did we say of meant? What operation does of mean? We worked on this a while ago when we were doing tape diagrams. Of means to multiply. So if I'm saying 10%, and I'm saying 10% is 10 over 100, isn't that the same thing as saying 10% is 1/10 of 64. Is that the same thing? Instead of 10%, I wrote 1/10. Instead of, I wrote multiplication. So 1/10 times 64. Nicole, you want to sit up here? Would that be easier? So what is 1/10 times 64? That equals 64 over 10. I know that my fraction bar means to divide. So 64 divided by 10 is what? You could do that mentally. What is that? And if you don't need to do it mentally, you solve it out. Yep. Let's try that method again. 10% is 10 over 100 equals what part of 5? So 10% is 1/10 of 5. So that's 5 over 10, and that equals 0.5. Now, I better be careful here because the directions told me one of them needs to be a model. So I'm going to use my model for F. 10% of what number is 48? So this is 100%. I don't know my of. I don't know the total. I do know that 10%, here's my percents along the bottom. I do know that 10% is 48. So 10% is 48. So I know each box has a value or a constant of 48. So what is 48, 48, 48, 48, 48? I hate when it does that. Well, there's 10 of them, so it's 48 times 10. That's right. All right, good. I got my model out of the way because it told me I had to use one model.
How is 480 10% of 48? Oh, number.
Okay. 10% of, I don't know what my of is 6. So I can reduce that to 1/10. So what is my total number? Very good. All right, so we're coming up with a lot of evidence to support our claim.
I have a question for you. Like, couldn't you just, like, divide because, like, 5, like, first number D, like, can you divide?
You could have reduced it. All these methods will work for all of them. You can pick and choose which ones you want to use. They all work for all of them.
Obviously, it's like how you have to answer, like, 45.
Gary read 34 pages of a 340-page book. What percent? So I don't know my percent, but I do know 34 of 340. How can I reduce 34 over 340? I have to reduce it because I can't get from 10 to 340. Well, can't I divide them both by 34? So x over 100 equals 1 over 10. So now I can figure out what the percent is. So what was the percent? Well, let's see. To go from 10 to 100 times 10. So I have to do the same thing to the top. So 1 times 10 is 10. So my answer is 10%. He read 10% of his book. Yes.
How would you get 34 and 340
Divide by 34. Divide by 34. So 34 divided by 4 was 1. 340 divided by 34 was 10. Okay?
How do you know that, like, first?
All right, Michael read 16 pages of his book. 16 pages of his book. If this is 10% of the book, how many pages? So they're telling me 16 pages is 10%. I don't know how much the whole book is. So 10% is the same thing as 10 over 100. 16 is part of the whole book. Can I see the relationship between these two right away? Can I get from 10 to 16? No. So I'm going to reduce that to 1/10. Now can I find a relationship? 1 times 16 is 16. I have to do the same to the bottom. So x equals 160. So there are a total of 160 pages in the book. Let's take a look at how we set this up. 16 pages is 10%. So my 16 pages and my 10% go next to each other because I know that they have the same value. It says 16 is, so that goes in my is spot. Now 10% is always out of 100. So that's how I knew to set it up. My of, I don't know what my of is. I don't know the total of the book. So that's why my of is my unknown. Okay? So now what I did here on the next page, you don't have this in your notes, but just look at the board for now. I made a table that summarized everything that we just found. So 10% of 300 is 30. 10% of 80 is 8. 10% of 64 is 6.4. And so on. Those are all the problems that we just solved. Now, if we remember, the claim that we made was to find 10% of a number. All you need to do is move the decimal to the left once. So our decimal always appears at the end of the number if it's not given. Did we move the decimal one place to the left?
Yes.
Yes. Yes. Did it work every single time?
Yes.
So did we prove our theory?
Yes.
Yes, so the statement is true. So on our notes, we're going to explain that. The claim is true. It's true because when I find 10% of a number, what am I really doing? I am really finding 1/10 of that number. And another way to say that, remember, multiplying by 1/10 is the same thing as dividing by 10. Remember, multiplying by 1/10 is the same thing as dividing by 10. We talked about that a lot when we did our tape diagrams. I don't understand why you're not copying all of this down. There's a big space in your notes for it, and you should be copying it down word for word. Remember, make math matter. Complete, accurate notes. You need to have this written down word for word. Okay. Well, now we have another claim. This claim is going to state, if an item is already on sale, and then there is another discount taken off at the new price, then it's the same as saving the sum of the two discounts from the original price. All right, a lot of times I'll go to a store and I take out my special wallet that's got all my coupons in it. So, if I use my 30% off coupon, I can't use my 10% Super Savers card. So, all right, what should I do? If I'm buying this shirt, should I just take the 30% off? Or should I go with the 20% off and then they'll take another 10% off with my Super Savers card? So should I use my coupon or go with the sale and my Super Savers coupon? So right now on your paper, make a prediction. Is this true or false? Is it true that it's the same thing? Or is it false that it'll be different amounts? Go ahead and write your claim. Take a chance, nothing to lose. All right, let's see if we can prove this right or wrong. And the directions said when that we prove it, we need to use at least one model. So why don't we use the model first to get it over with, okay? Sam purchased 3 games for $140 after the discount of 30%. What was the original price? So I have to find my total. So I know that I could use a tape diagram. So 100% is my total for percentages. I don't know the original price. I don't know what the whole cost was before they took the 30% off. Now they're talking about 30%. So this is the 30% that they took off. They took that 30% off. This is the 70% that I paid for. So if I paid 70%, I paid $140. So I had to take that $140 and split it up into those 7 boxes that represent the 70%. So what is the constant? What is each box worth? If $140 equals 70%, 20. So 20 is my constant. So if 30% is 3 20s, and that's what they took off, how much did they take off? They took off $60. I saved $60. So if I paid $140 and I saved $60 and I have 10 boxes of 20, what is my total amount that I paid for the video games? $200. And you should write that in a sentence, circle it, label it. The original price was $200. Okay, so I'm going to keep that in the back of my mind. $200, 30% off, $140 I paid. Okay? I'm going to go ahead. Price with the 30% discount was $140. You're just going to hold on to that. All right, now, let's try it the other way. First, we're going to take off 20%. Then, when I get my new price, they'll take off 10%. So let's try it. So first, let me figure out my first discount. So my first discount is 20%. 20% is 20 over 100. So how much am I going to save if my video games cost a total of $200? What am I saving? I don't have to do any reducing. I can see the relationship right here. Okay, so X equals $40. He was able to figure that out because 100 times 2 gave me 200. So 20 times 2 is 40. So my first discount is going to save me $40. So let's see what the price is. So I'm going to come over here. If $200 was my original price, minus the $40, because that was my 20% discount, What did the video games cost me? Right, so now the new cost is $160. Woohoo, pretty good. But I'm not done. Now they're going to take off another 10%. So let's see how much it is. So now my second discount starts at $160. We're not at the $200. My new price is $160. What did we notice from the first half? If it's 10%, how much am I saving? Whoop, I could just move the decimal 1 over. So how much am I saving? Uh-huh.
You're saving.
It's $160. And we claimed that 10%, we just moved the decimal over 1, where I'm saving $16. If you're not comfortable just moving that decimal over 1, you can still set it up. We can set it up. 10% is 10 over 100. How much am I saving out of $160? 1/10. Okay, so the second one I'm saving $16. You could set it up either way. All right, so after 20% was $160 minus my second discount of 10%. What is the price of the 3 video games? What's 160 minus 16?
144.
Okay. I'm going to pause to make sure that you have a second to copy all of this down, left to right, exactly like I have it on the board. All right, now let's use both pieces of information to prove or disprove the claim. So the price with the 30% discount was $140. What was the price with the 20% and then the 10%? So, was the claim correct that when the item is already on sale and then another discount, that it's the same as the sum of the 2 discounts? Is that true? No. No. So let's explain why or why not. I mean, sorry, it's been a long day. Let's explain why. When 2 discounts are taken off, the shopper pays more. God bless. Now they want us to prove it with another example, one that we've come up with on our own. So let's come up with one that's really easy. Let's just do it out of $100. Okay? So I'll come back to that at the end of class if we need more time. So let's take a look at this. Copy this on your notes. I made a little chart to help us organize. So if $100 was our original price, let's compare a 20% discount versus 2 10% discounts. So 20% is 20 over 100 is how much out of $100? How much am I saving on a $100 item if it's 20% off? Everybody?
80.
No. Somebody else instead of everybody. I'm saving $20. Look, there's an equal sign. If I put an 80 there, does that equal that? No, that doesn't make sense. So if it's a $100 item minus a 20% or $20 discount, my sale price is $80. Now let's try 10% discounts and see if we get the same thing. So 10% is how much out of a $100 item? $10. So my item is $100 minus a $10 discount, so my price is $90. But now they're going to take my $90 and give me another 10% discount. Woohoo, another discount. How much am I saving with my second discount? How much am I saving with my second discount? What did we say about 10% discount? You're just moving the decimal. So how much am I saving? I'm saving $9. So my new price was $90 minus my $9 discount. My sale price is $81. Does this support the claim that 2 discounts is not the same as 1 discount? Right. You're better off with the 1 discount than the 2 discounts.